So I'm Chris Swan. I'm CTO at a cloud networking company called CohesiveFT. I'm also a cloud editor at InfoQ, where I've been writing a little bit about Docker. So this title of the talk seemed like a good idea in March when I was asked to come here, because Docker was a year old then, and it seemed that a lot had changed in a year. And 8 months on, things have changed some more, and that's what I'm going to be talking about. So the sort of too long, didn't read version of this, the summary of what I'm going to talk about is Docker. Yeah, we're on the DevOps track here. Docker, I think, is important for DevOps because it tightens iteration loops. And I think tightening iteration loops is a kind of key objective for moving faster and delivering quicker. The core project developed really fast, and I think back in March, when we were talking about what had changed in a year, the core project had just about reached a sufficient level of maturity that people were starting to build things around it. But what's changed in the last 8 months is I think we can see the Docker ecosystem, so things that people are building around Docker are now moving even faster than the core project itself. And that means that there's a whole ton of great stuff arriving that we can do useful things with. And then if we ask ourselves the question, how did all of this amazing stuff get delivered in a year and 8 months? I think the answer turns out to be they did it with Docker. So because Docker is allowing us as developers and engineers to tighten our own iteration loops, it's also tightened the iteration loops for the people making Docker and the people making things with Docker in the Docker ecosystem. And so it's become evidence of its own success that Docker changed a lot in a year because Docker is effective at changing things. So some of you are probably asking, why me? This guy who does cloud networking and writes a little bit about Docker. Well, where does my own experience of this stuff come from? So going back a bit, I used to work in financial services industry, and one of the things I did in the financial services industry was I built grids. And grids were kind of the edge of scale at that time. So if you were building something with a few thousand nodes, then that was pretty large scale. And if you were building something with tens of thousands of nodes, then that was as big as stuff got apart from Google. And I think grids, to a certain extent, evolved into what we now call cloud computing. And I started using cloud computing really as soon as it emerged on the scene. I was one of those weird people who had an Amazon Web Services account before there was Elastic Compute Cloud, because there was actually a bunch of web services before there's the web services we think of today. And CohesiveFT was born around about that time as well. A cloud native company initially delivering virtual machine management. And then the networking stuff came about because as soon as people could move things from one cloudy environment to another, then you needed some way of connecting that stuff together and connecting it back to enterprise systems of record and that kind of thing. And that's a journey I've been personally involved with for a little over a year and a half now, which is roughly round about the time that Docker came out. So as Docker was coming out, I was starting my new gig. And last summer, we decided to put Docker into our product. So we'd had customers kind of coming to us and saying, oh, I've got all of these things that I'm running in itty-bitty VMs on the edge of my application. Can you please just put the functionality into your core product? And we were faced with this sort of exploding test matrix of doom, because it was okay for each individual customer to think that their request was reasonable to put Nginx or HA proxy or Varnish or whatever it was that they wanted into our core product. But if we did that for every customer, then we just wouldn't be able to manage the complexity. And so what we did was this. We put a Docker subsystem into our product, and that lets people take what they would have otherwise run as a standalone VM and instead containerize it, and they can have their SSL termination or their load balancing or their content caching or their network intrusion detection as things running in containers rather than as things running as standalone VMs, and that cuts down on cost and management complexity and security surface area. So it's a big win all around. Now, when you end up incorporating somebody else's fast-moving open source project into your own product, you get to know it very well, and especially I've got to know more than I ever wished to about Docker networking in particular and Linux networking underneath it in general. And that's a completely different talk, so I won't be talking today about Docker networking. So this is the DevOps track. Why on DevOps do we care about Docker? Well, I already said in the summary, I think it's about moving faster. And who in the room's already heard of John Boyd's OODA loop? Yeah, Adrian Cockcroft talks about this, but there was only a smattering of hands there, so I'll go over it for those who haven't. So John Boyd was a US Air Force pilot, and he saw active frontline duty in the Korean War. So he was flying Sabres, the things on the top left, and him and his comrades were getting their asses pretty much kicked by the MiG-17s being flown by the North Korean pilots, which they'd got from the Chinese, because the MiG-17 was more agile. And when he subsequently went on to become a sort of Top Gun type instructor within the Air Force, he came up with this thing that's now known as his OODA loop. And OODA is observe, orient, decide, act. And he said, when you're a fighter pilot engaged in a dogfight, you're going through these processes of observe where your enemy is, orient yourself to him, so orient your aircraft to him, decide what you're going to do. Am I going to go in there and engage with guns, or am I going to fire a missile and try and take him out from a long distance? And then act upon that. And the pilot that wins the dogfight is the one that can go around that loop the quickest, that can iterate fastest. And I think when we come to think about software, we see a very similar sort of thing going on in software. So we build software, and then we need to test software, and when we test the software, we find that there's bugs, and we need to go back and change things. And we're going round and round these loops. And organizations that sort of win in the competitive environments are the ones that can move the fastest and iterate the fastest. So this has been kind of the heart of the Netflix story. They decided to become a company that was designed for speed and adaptability to their marketplace, not a company that was designed for stability. And as a result, they've moved faster and they've been able to be very successful. And I think from an IT perspective, we now learn a lot from Netflix. This aircraft on the top right, the F-16, John Boyd became known as the father of the F-16. So what he said was, since we need to go around these loops faster, we need to be more agile. And one of the things that's distinguishing about the F-16 is it's an inherently unstable aircraft. So the aerodynamics of it means that it's not very good at flying in straight lines, but it is very good at turning. And so because it's inherently unstable, it can turn very fast, which makes it agile, which means that it can win dogfights. The problem with not being able to fly in straight lines is solved for us by computers. So the F-16 was one of the first fully fly-by-wire aircraft. And it's the computer that keeps everything stable by making tiny adjustments to the control surfaces of the aircraft as it's flying through the air, so that in regular flight it can appear to be stable, but as soon as the pilot pushes the joystick over, then he's going to break into his turn. So it's these kinds of agility that we're looking for in our software environment, and it's my assertion that Docker helps us go round these loops very much faster. Sometimes I do a demo at this point of Dockerfile. So who's seen Dockerfile and how to play with that? Pretty much everybody. So I'm going to skip past the demo, but the whole point of the demo is if I go and change something in a Docker file, say a single line of configuration, I've done my test and something isn't quite how I like it and I need to go and change a single line of configuration. Because Dockerfile is caching everything that worked before, I'm just kind of expending my effort. I'm just rubbing on the piece that was wrong. I'm rubbing away on the mistake. So I'm not doing all of the grunt work of reinstalling everything that worked. And I think many of the mechanisms that we had prior to Docker meant that if I was changing a single line in a single config file, I had to do everything else that worked first before the world would let me change my single line. And with Dockerfile, because of all of that caching it's doing in the union file system, then I get to change my single line. And the only thing that I'm waiting for to change is my single line. So I can move really, really fast. And I can take things that I would have been waiting, some cases as much as hours for if I'm building new VM images. And I can have those essentially instantly if I'm building Docker container images instead. It does result in a phenomenon that I've heard described as Dockerfile Jenga, where certain things within a Docker file can take some time, and other things within a Docker file are really quick. So it's kind of some of the early stage stuff when you're doing installation from Unix repositories, that can take an age. And it's kind of, you want that stuff at the top of your Docker file, because once you've figured out what your dependencies are, you're probably going to leave that alone. And then later on in the Docker file, you get to the nub of the software that you're working on, and you just want that bit to be the bit that you're changing. Because if you change something too early in the process, then everything after it has to be changed as well. And so it's like when you've got a Jenga game and you push something too low in the whole pile of wood and it all falls over. All right, so let's have a look at Docker itself. And I'm going to go back to the beginning. So the first release of Docker was described as 0.10. It came out in March last year, 23rd of March. And here was a platform that was based on LXC, Linux containers. And right from the very beginning, there was a registry there so that the system could push and pull images. And I'll return to why I think that that's so important in a sort of later stage in the talk. But that was there from the very beginning of the release of Docker. So title of the talk is What Changed Within a Year? So let's look back to where we were a year ago. So actually, there was a release a year and a day ago. Who wants me to read out all of these different change notes? Nobody. Yeah, it's an eye chart, and I've got no intention of going through it. But you can go into the GitHub log, and you can see what was there. And this was not really an epic release. This was a whole bunch of trivial stuff that people were fixing up. And at that point, we still didn't have a whole bunch of things that I think have come along later and are actually really important. So we didn't have a regular release cycle. So Docker was changing in sort of fits and starts, and kind of nobody knew when new stuff was coming or could be expected. At that point, you really did have to kind of bend things out of shape with your Linux distributions in order to install Docker. So you had to get exactly the right kernel release, and that involved a little bit of poking and fiddling in most cases. There was no linking between containers, so there was no kind of metadata mechanisms by which you could describe a relationship of one container to another. And so really you were kind of on your own building things in single containers and figuring out how to get them to go together. And kind of associated with that, there was no concept of naming. A great deal of those things came in the 0.7 release, which was the end of November last year. So as of just a little under a year ago, we started to get these things. And I think many of these things, if you're using Docker today, you've kind of already taken those for granted. So the watershed release, I think 0.9 was the release that kind of made Docker what it is today. And one of the major changes that came in 0.9 was Libcontainer. And it was at this point that LXC got thrown under the bus. So Docker had been a wrapper for LXC, and the Docker project decided that actually they would rather do the things that LXC does themselves. And so Libcontainer, the default mechanism now for Docker is it's not configuring control groups and namespaces and capabilities and mandatory access control and all of those things through LXC, because actually some of those things can't be done through LXC, such as Mac. And instead it's doing it itself using Libcontainer, which is a native Golang library. The other thing that's kind of important about Libcontainer is it's essentially a pluggable architecture. So Libcontainer can drive LXC, and it can drive Chroot, and it can drive OpenVZ. So you can take all of these different approaches to containment and have a unified interface to all of those things, but you're getting mixed results. So Chroot is going to give you nothing like the containment capabilities of native Libcontainer itself. But what it does mean is that there's now the opportunity to have higher strength container mechanisms which can be driven by the same API and the same tool chain. And so VMware's been working on that with their Project Fargo. We saw Ubuntu announce last week LXD, which they're describing as a hypervisor for containers. And that's causing quite a few sort of stirs within the industry of, so what exactly is all this stuff going to achieve? And are Ubuntu forking the industry? And nobody seems to quite know what's going on there. There was a patch to 0.9 a couple of weeks later. So 0.91 fixed a bunch of bugs. And 0.91 is the Docker version you will get in most of the distros at the moment. So Ubuntu Trusty Tar here got 0.91, CentOS 7, and quite possibly even RHEL 7 are going to get 0.91 as well. This is, unfortunately, I think, a bit of a mess. That we've got to Docker 1.0, we've got to Docker, in fact, 1.3 we're at now. And if you just go into regular Linux distro and apt-get install their thing that gets you Docker, and it's not called Docker, because there was a project called Docker before there was Docker. And so it all starts to get a little bit nasty and confusing. I think in Ubuntu it's called docker.io, and they don't even call themselves docker.io anymore. They've gone to docker.com. And if you do that with Ubuntu, then the command line is called docker.io rather than Docker. So that's not good. If you're installing Docker, I'd suggest not actually using a native package library from a distro. Just go to the Docker homepage and see what the distro-specific instructions for getting the latest version are, because you probably don't want to be on 0.91, which was sort of a March release from this year of a project that's moving quite so fast as it is. So and then came DockerCon. So June brought us DockerCon, and DockerCon brought us Docker 1.0. So weekend before DockerCon, they'd done one of their regular monthly releases, which had been 0.12. And first thing, morning of DockerCon, this appeared on GitHub, and it's kind of nothing changed. So 0.12 to 1.0, production support. So nothing changed in the code base. They just anointed that as the one that they were willing to look after in a production supportable environment. There was a bunch of other kind of super important stuff came along at DockerCon. So Libcontainer itself wasn't a new thing. We'd had Libcontainer since March. But there was a whole bunch of announcements about partnerships based upon Libcontainer, as the industry was kind of saying, okay, we're going to do more interesting things with Libcontainer, or we're going to make Libcontainer part of our own services. What was new was LibSwarm. So LibSwarm is a set of APIs for orchestration. I'm going to talk a little bit more about orchestration towards the end of the presentation. But one of the kind of problems that was starting to emerge was everybody was doing their own orchestration. And in principle, that meant that we were going to face a situation where it was just going to become an integration nightmare. And I think it was quite prescient of the Docker team to get in front of this and say, let's have an orchestration API that everybody can interface into, and at least then we've got a single point of convergence for orchestration. The other sort of big announcement from Solomon Hykes on day 2 was LibSwarm. So LibSwarm, he described this as kind of the networking thing for Docker. And there's a whole bunch of interesting things happened subsequently with networking, such as Weave. And the past week, there's quite an interesting SDN proposal built around Open vSwitch appeared in GitHub. But libchan is in my view, not actually about networking. It's about communication between different processes. So it's taking the Go channel mechanism and it's making it work across the network. And I think this is fairly and squarely aimed at making the internals of Docker work across a distributed environment. And so what we can expect to see grow from that is, rather than Docker being something that we use on a single host to control containers on that single host, it's something that we'll be able to use across a group of distributed hosts. And so this becomes a sort of underlay channel mechanism, and we can expect that to be used in distributed things that aren't necessarily being driven by a higher level orchestration. So in terms of the Docker core, what's happened since 1.0? Well, not a great deal, actually, and I think that's a good thing. So it got declared as stable, and stable things shouldn't change a lot. So in terms of incremental functionality, we've seen really these two new commands come along. So exec and create. Exec addresses the issue of basically container maintenance. So there's this sort of religious debate been going on of, should containers just be a single process? The purpose of a container in life is to run a single process. Or should a container be like a mini VM and have an SSH daemon and you can log into it remotely? And if you kind of went with the religion and said it's a single process, then you had a problem, because if your single process wasn't attached to a terminal, then how did you communicate with your container after you'd made it? And if you bought into the whole immutable infrastructure thing, and it's kind of, you built special purpose containers and then you threw them away when you needed a new one, that was fine. But lots of people aren't doing immutable infrastructure and need to kind of go back in and do maintenance activities. So there was a project called NSEnter, namespace enter, which came along and allowed you to get a terminal inside of your container once it was up and running and serving its purpose and running its process. And Docker exec from the command line is basically taking that same capability that NSEnter gave us and making it part of the official toolchain. Docker create is a little bit more mundane. So Docker create is basically saying, I can make a container without running it straight away. So when we did Docker run, we would create a container and run it. And some people said, well, I want to create a container, but I don't want to run it. I just want to make it be there, and I'm going to come along and run it or do something else with it later. And that's what create is there for. So moving on to the ecosystem and kind of other things that have been happening around Docker, and I kind of summarize this as shocker, flocker, clocker, and what else can you think of that ends with ocker that you're going to name your project or product after. So shocker, this isn't a great example of the ecosystem, but it's really important. This came out in a matter of days after the 1.0 release, and it was a proof of concept attack against the containers. So it was basically showing that you could break out of the containment mechanism. And the response to shocker is very important. So Solomon Hykes, who I guess is our benevolent dictator of Docker, came along and said, when we feel confident for you to run untrusted root programs inside of your containers, we'll let you know. So my opinion is that that day will never come, or if Solomon does say that we can do that, he will be proven wrong shortly afterwards. But Shocker was a good example of the community kind of working on at least evidencing where we are with containers and security, and I'll come back to security stuff. Flocker. So Flocker is about state management, developed by the Cluster HQ guys. They're really pushing hard on ZFS on Linux and building something that can give you synchronizable state between containers. And I think this is possibly one of the more important projects that's going on. Because if we look at how people are using containers, a lot of it is kind of third generation application architectures, 12-factor and all of that. And I love all of that stuff, but it assumes magic state management in the sky. And so state is still a real problem. And I think dealing with state using something like Flocker is potentially a real solution for that. And then Clocker. The guys from Cloudsoft, who've been doing the Apache Brooklyn project and stuff like that, figured out that you could take what they've been doing, which is all about packaging builds of things, and you could apply that to Docker containers as well, and so they called that Clocker. And actually, I think Clocker is just an example of composition. So Clocker comes from a heritage of composition that existed before we had Docker, but Docker has come up with all of its own composition frameworks and toolkits. So first and foremost amongst those is Fig. So Fig was developed by a startup called Orchard Labs. Orchard were one of the first bunch of guys to kind of produce a Docker service, somewhere where you could just show up and run containers. But as a kind of value-added thing to the community, they developed this thing called Fig, which was a way of taking multiple containers that formed an application and describing in a single YAML file how the containers interrelated. So without Fig, to get a simple 3-tier application running, I'd have to have multiple single Docker run commands that would start individually each of the containers and contain the associated metadata to describe names and links. And what Fig does is it takes all of that metadata, encapsulates it in one thing, and then I can just have that YAML file and say Fig up, and it's going to launch all of my containers for me. So it kind of greatly simplifies some of the complexities of multi-container deployments. So Fig weren't the only people doing this. So Red Hat have got their thing. They call that Gear D, and that's become part of Red Hat's Project Atomic and some of the other Red Hat initiatives going on around Docker. And then there's Panamax. So Panamax came out of CenturyLink Labs. They describe it as Docker for humans. You could almost be sarcastic and say it's Docker for dummies. And so Panamax is a visual compositing tool driven out of a web UI. So I'm actually showing a screenshot of the CLI that you get with Panamax. But the CLI is really only used for sort of lifecycle management of the Panamax environment. And once you've started that up, you've got a web interface where you can essentially generate from the web these YAML files that you might use in something that looked a bit more like Fig. But it's also got a repository, so you can take other people's YAML files for multi-container deployments. You can start manipulating those yourself, and then you can contribute them back to the community. And they had quite an interesting competition associated with the launch of that, trying to get the community to build templates and offering Mac Pros, the cool dustbin-y, super powerful PCs as prizes for that. So PaaS caught Docker. So we ended up with Docker-based PaaSes, and so you got Deis and Octahost and Doku and Flynn, and so people were kind of taking things that had been done with PaaS elsewhere and doing them with Docker. But I think more importantly, we ended up with Docker inside of the mainstream PaaSes. So pretty much all of the big PaaS projects now have got some kind of Docker involvement. So Colin's not in the room, I don't think, but Colin Humphreys did Decker. And that was one of the first sort of proof of concepts, really, of taking Docker containers, running them inside of a PaaS. But subsequently, Apcera, so that's Derek Collison's company, where he'd been involved in founding Cloud Foundry and then said, okay, I'm going to do essentially Cloud Foundry 2.0, but I'm going to do it as a separate thing. So Apcera Continuum has got Docker container import capabilities in it. And then along came Diego, which is basically the official mechanism of putting Docker containers inside of Cloud Foundry. So PaaS and Docker are now kind of working together and all happy. And I think if PaaS has a problem with developers because it's opinionated. So PaaS pretty often makes people have less choice about their languages and less choice about their frameworks because they're kind of being inflicted by the PaaS. And I think Docker might just be the anti-PaaS. So Docker doesn't inflict any choices upon you. You've got a completely open book of choice. You can just essentially, with Dockerfile, go back to entering in stuff on the command line just like you would do manually, which means you can run anything and you can have any framework. And so if we think about taking opinionation away from PaaS, if we're no longer making PaaS be about a language or a framework, then what is a PaaS about? Well, the residual piece is it's about operationalization. It's about configuration management. It's about control and monitoring of your environment. It's about the ability to achieve scale without having to jump through a whole bunch of hoops. So I think this is where orchestration comes in. Because when we start looking at orchestration frameworks, they are basically giving us those operational pieces that we get from PaaS, but without inflicting choice of language and framework and being opinionated. So this was the news from DockerCon. It's kind of everybody has their own orchestration framework. And I love this tweet. It's kind of what I learned today at DockerCon. Everyone is building their own orchestration platform. Seriously, everyone. And we had the Mesos guys showing off Mesos and also Mesosphere, which is a different thing, but based upon Mesos. We had Facebook talking about Tupperware. So Tupperware is the container management platform that they have inside of Facebook. Facebook hasn't moved to Docker containers yet, but they have been running containers across their entire infrastructure for some time. And then Kubernetes. So Kubernetes has been sort of born out of Google's use of Docker. The whole Linux container story started with Google. So if you go back to the C group's kernel changes, that originated out of Google because Google wanted to run containers within their own data center. They've now got this awesome platform called Omega, which they use for scheduling and orchestration across their containers. And Kubernetes is basically a Golang baby brother of Omega. And there's a whole bunch of stuff that they've already done with Omega that they've not baked into Kubernetes, but they have gifted Kubernetes to the world. And so I think Kubernetes is becoming the one to watch because it's already been adopted by Microsoft, so you can get a Kubernetes-based service off of Azure. It's been adopted by IBM in their soft layer cloud, so there's Kubernetes-based services there as well. And then as of just this week, we have Google Container Engine. So there's an alpha product being launched by Google based upon Kubernetes, allowing you to get orchestrated containers on demand on their cloud. And that's kind of cool, but I will say that, caution, this is not yet the containerized cloud. So I am expecting something to happen where we'll be able to go along to services and get containers on demand, and it will move the decimal on price, and because containers can move the decimal on so many other aspects. But this is not it yet. So if we look at the pricing of Google Cloud Engine, then it's still based upon VMs under the hood, and they're still billing you for VMs under the hood. And so nothing fundamentally has changed. So they've just put the Kubernetes orchestration in there. So why does all of this matter? Well, I think it matters because in the end, build and ship are more important than run. So people say to me, oh, Docker's boring. Containers have been around for decades. What about zones? What about LPARs? Like, yeah, sure. Containers have been around for ages. And LXC came along on Linux, and I think actually still then it was sort of boring. And what Docker has brought to us is ability to have a unified build environment for containers and a way of moving those containers around, whereby we can do that within our own organizations and we can share them with the rest of the world. And that's much more important than containers themselves. Containers themselves just become the runtime substrate for that. So Docker Hub is now this kind of public resource that we've got where not only can I upload my containers or upload my Docker files to make containers out of, but anybody else can come along and share from that, as we've had with source code for a long time now with GitHub. And what this essentially gives us is bottled software. So I love beer. I love brewing beer. But when I brew beer, it takes months for my beer to be ready. So if I want to drink a beer, then I would rather go and get a bottle of beer because I can drink it right away. And this one, far right, Pliny the Elder, that is the best. So if you can get hold of that stuff, I would highly recommend it. So what this means now is if I'm starting to use a new tool, I don't have to do the thing that I did before of installing that new tool and figuring out how that new tool integrates with a whole bunch of other tools that I might be using around an ecosystem. Because it's almost certainly the case that somebody else has already done this. And it's increasingly become the case that not only have they done it, but they've made a Docker image out of it, or they've made a Docker file to build one of those images. And I can just go get that out of Docker Hub. And so instead of spending hours figuring out a new tool and installing it and integrating it, I can just get somebody else's bottled tool, and I'm off to the races. I'm immediately productive. So that's saving a whole ton of time. That has happened for real for me personally with the Azure toolkit. And I recently spent far too many hours of my life wrangling the WRT node SDK. But if you want to do development in WRT node, you can just go and get my version of the SDK from Docker Hub, because you can get that in a matter of minutes now. There's still a whole bunch of work to be done. Yep. So Docker Hub already has stars, and Docker Hub already gives you how many times an image has been downloaded. So you've got that kind of coarse-grained reputation system in there. What they're working on now is provenance. So where did stuff come from, and can you trust it? Or is it even reasonably dependable? And there's also already problems with bad actors in there. So there's this random guy in Canada called Pilwon who decided to register the name Docker file in both GitHub and Docker Hub, and that looks too official. And lots of people think that it is official, including the Amazon Web Services guys who originally used Dockerfile /nginx as their example for Docker on Elastic Beanstalk. So yeah, this stuff needs to be cleared up. Right. Problems. Containers don't contain. So I'm not going to do the full security talk. Dan Walsh did a great talk at DockerCon, and everything he said is still, I think, as relevant now as it was then. So this was the illustration he used, which I think pretty much sums it up. I think there are methods by which we will get runtime environments that offer containment. So I already touched upon Fargo and LXD. I don't think containers ever will contain. So if you look at what containers are made out of, C groups, namespaces, kernel capabilities, mandatory access control, four-dimensional problem with dozens to hundreds of configuration options in each of those dimensions. I challenge anybody to come along and tell me, oh, we figured out the right ones. This is the secure settings. You know, we got the knobs and dials to exactly the right positions, and that is secure. Because there's just too much variability there. And so that's why I think containers never will contain, but I think people will figure out ways of working around that. There's also what I call the manifest problem. So if we go back to a Docker file, each entry within our Docker file is building a layer in the union file system. And then we take all of those layers and we bind those together into an image, and that image becomes our unit of deployment. And yeah, if we're just taking something like Nginx, then I could say that that's my Nginx example. And I now don't know what version of Nginx is inside that. I've got no idea. It's just whatever version of Nginx got apt-get installed at that point in time. And that turns out to be bad because I don't know which version of OpenSSL went into that Nginx either. So when something like Heartbleed comes along, I've got no idea whether I need to patch it or which bash. So shell shock becomes a problem for me as well. And so this isn't a Docker problem. It is the fact that Docker is causing a proliferation of containers and container images, which will probably be an order of magnitude worse than VM sprawl. And this is really a Linux package manager problem, and we have not been very good at paying attention to what package managers are putting into deployable artifacts. And I think we're about to cross into a sort of scale where it really will get completely and utterly out of hand, and we're probably going to have to fundamentally reappraise how we think about dependency, how we think about how things get into deployable assets, and how we keep track of what we have in production. And so, there are ways where I see some hope. So there's things like Nix, which is a functional package manager, and Nix Docker, which Zeph Hemmel made around that. So I said I would talk about a Docker wish list. It's kind of how we're going to make it get better. So back in February, I did a presentation at QCon, and this was my Docker wish list. So I wanted a Docker CLI. I get sick of doing sudo docker blah, blah, blah. I just want to do sudo docker and jump into the Docker CLI and then say run and kill and do all of my Dockery stuff. And Solomon said at the time that that was super easy and a good idea, and it still hasn't happened. Disk quotas are a big issue. So one of the potential problems with running a whole bunch of containers is one of the containers can swallow up a whole ton of disk with logs and whatnot, and there's really no way of stopping that. And back in February, I was concerned about root propagation, but that was possibly because at the time I still just didn't understand the Docker networking well enough. So here we are in November. I'm still waiting for my Docker CLI. I'm still waiting for somebody to do something about disk quotas. And Docker have changed the way that they deal with restart behavior, which is making me want to have finer control over lifecycle. So I can now set flags about how I want a container to be dealt with when it exits. But I don't find that they're actually dealing with what happens when the daemon is restarting. So if I'm bouncing a VM that's got Docker inside of it, I'm not really having the control over the life cycle of those containers as it comes back up. The message actually is that if you want to have a better Docker, get involved with the project and make it better yourself. Because this, although there's a commercial entity around it, this isn't like the old world where we're customers and we make feature requests and other people go off and do that. For sure, you can throw something onto GitHub issues and say, I wish Docker did this, and that will probably be ignored. Whereas if you write some code and do a pull request, somebody will do something about that. So if you want a better Docker, learn Go, because that's what it's written in, and start submitting your pull requests. So there's a whole bunch of other things that are happening, which it would be sort of rude of me not to mention. So Windows is going to get Docker. So Windows 10 and the server-based version of it, there's been a partnership announced with Microsoft. Windows is getting a package manager as well. I mean, it's almost like it's catching up with the modern world. So last week was the first meeting of the Docker governance board. They've set up a foundation around it. They've sort of got Solomon as benevolent dictator, but they've got a whole bunch of people trying to keep him on track. And these are the 4 things that kind of came out as the key points of the first meeting. So they want to have a more mature tooling and continuous integration process for the project so it can scale a bit more. They need to deal better with long-standing pull requests, so figuring out how to unclog the pipeline for those. It has been decreed that there shall be a clear separation between Docker Inc. and Docker, the open source project. And there was also clarification on the relationship with Microsoft, so they're not going to have kind of special access. Everything that Microsoft's doing is going to be out in the open and visible by all. And a clear articulation of the roadmap. I think if you look at other large-scale open source projects that have maybe not satisfied people, OpenStack, I'm thinking of you. One of the things that's been lacking there is a vision for people to work against. So what happens when you don't have the vision is people just do all kinds of random nonsense. And I think articulating a vision for Docker's roadmap will be a good thing. Solomon tweeted this just this morning. So they need more maintainers. And I think he's trying to elevate people's esteem of maintainers to try and encourage more to come along. that a maintainer is a contributor of decisions and not just code. And this right now, I think, is the bottleneck to the core Docker project getting better quicker. Is there's just so much going on that they don't have enough maintainers to go around. So, nearing the end, how did we come so far so fast? Well, I think we came so far so fast because the people that have been involved with the project, they use Docker. So they've benefited from the output of their own ecosystem. And so wrapping up then, I'll kind of return to my summary of earlier. Docker is important for DevOps because it lets us iterate faster. It's tightening those iteration loops. The core project has developed very fast, but the ecosystem around it is now kind of outpacing it. And I think that is in part because the core project has satisfied a whole bunch of objectives, but there's also some sort of governance and maintainability aspects to that. But whether you're looking at the core project or whether you're looking at the broader ecosystem, it's evolved so fast because they did it with Docker. Thank you very much for listening, and we've had one question already, but I'd love to take some more. Anybody? Okay, no questions. I can't believe it. Oh, you've got another one.
What about the business side of things? What's the roadmap for partnerships and services, and how are they going to make the money?
So the question is, how's Docker going to get a business model? And I last talked to their investors about this in June, so the story may have evolved a bit more since then. So in June, they announced commercial support, so they're going to start to make some money from that. It's a drop in the ocean. So they're taking, at the moment, much more investor money than they're taking revenue from selling anything. One of the Orchard guys, who's now part of the Docker team, said, we want to be spending customer money rather than investor money. So at some point, that commercial model has to come. I think they're still in the kind of business model discovery process. So, just like Twitter built an awesome service and grew it and grew it and grew it and didn't have a financial model for quite a while, they're building a company around an awesome open source project, and they just want to grow it and grow it and grow it and see what might work. I think there's all kinds of options. So support is just one of them. I don't think that that's actually going to be enough. An enterprisey version of Docker might be another. VMware's already taking a swing at that, and I think VMware might be ideally positioned to be the enterprise tollgate for the run piece of build, ship, and run. You can then say, okay, if somebody else might take run, what can Docker Inc. do with build and ship? So they've got Docker Hub. Another way that they're making a little bit of money at the moment is people having private repositories in Docker Hub. That could scale over time. And then there's other stuff that I think we just can't conceive of at the moment. I kind of expect them to eat a lot of their own ecosystem. And so things like Flocker and Weave and whatnot might end up kind of glomming together into making a more enterprisey sort of Docker offering. A lot of the investment community that I talk to at the moment is kind of going back a decade with where VMware was and saying, okay, what made VMware acceptable to the enterprise, and can we make these same qualities happen to Docker containers, and what's it going to take to do that, and how do I build a company around that? And I think at the same time, Docker Inc. is probably looking at exactly that same list and thinking, can we build that ourselves, or do we want to make early stage acquisitions to deliver that more quickly? So it's still in progress, and there's every possibility that containers might just turn out to be a $0 billion industry, and all the money's in services. So Google might be the ones that make the money out of it. Anybody else? Well, thanks for listening.